Okay, so again, equation, what's the equation of y versus x parabola? So we can figure out the high point. Okay? Now there's another way to figure out the high point. The high point occurs when your y velocity is 0, right? We're going to let's look at it both ways. Just get a hands in the mathematics, because you're going to need the mathematics here, the parabolas, okay? How do we get this equation?
Okay, that makes sense.
X is 5.1 meters per second times t. So that t is x over 5.1 meters per second. Well, y is what we say here, and t is this. So we substitute x over 5.1 meters per second for t, and we get y as a function of x, right? So that equals so simple substitution, just putting this in wherever t is, this is what we get. And conveniently, just because of the amazing coincidence, that according to our figures, I released this thing at 45 degrees, okay? Now this and this are equal. I'm going to cheat a little bit. This is pretty close to 5. So this 5, one of these 5s that I get when I square this, going to divide into this one. The other one will give me a 5 in the denominator, which gives me a 0.2. Whether you understand that or not. That's not exact. That really ought to be like 0.19 or something like that. Okay? You work out the arithmetic. But there's your equation, y equals x minus 0.2x squared. Okay, well, that gives you a vertex at x approximately equal to 2.5 meters. And a little digression. I can't find a place to write a little digression. Write it up here. Write it in a different color. y is 0 if x is one of these two values. That's your quadratic formula, isn't it? You should recognize that. You should ideally have been able to write it down at any point since you took Algebra 2. But curriculum doesn't reinforce it very well. Okay? So maybe you've kind of forgotten it. You should know how to derive it by completing the square. That's just a basic mathematical operation. Yeah, if not, you don't really understand it, and it's worth really understanding. So you might want to review that. Now, my big point is that this is where it's 0. Negative b over 2a is halfway between what you get if you use the plus and what you get if you use the minus. Because, of course, b is halfway between what you get if you do, negative b is halfway between what you get if you do negative b plus the square root and negative b minus the square root. Here's negative b. Here's negative b plus the square root. Here's negative b minus the square root. They're at equal distances because it's the same number, right? So b's right halfway in between them. And by the symmetry of a parabola, vertex is halfway between the zeros. So, now that's something in pre-calculus you're just told to memorize without any reasoning. But there's a symmetry argument, and it's a total disservice to people of your aptitude to do this without the symmetry argument. On the other hand, in our schools, we're trying to teach Algebra 2 to people who will never learn Algebra 2. So we don't get to tell people who can understand this what's going on. We have to spend too much time with people who either will not or cannot learn Algebra 2. I kind of disagree with that, but I do agree with the idea of doing what we can for everybody. So you're between a rock and a hard place. We decide what to actually do, but yeah, there's that aspect of it. You have that disadvantage, but you're smart enough to fix it. So fix it, okay? You want to totally understand where all of this comes from, how it works. It will increase your mathematical ability, which will be very beneficial to you in your chosen field, okay? And in this course. Well, we can use this to figure out where this is, and that's all I used. You know, A is negative 0.2, B is 1, right? So 2A is 0.4. So if we divide negative B by negative 0.4, 2A is negative 0.4, I don't know if I said the negative. Negative B would be negative 1, that's coefficient of x, right? 2A is negative 0.4, you get 2.5. Vertex is that x equals 2.5 meters. Now you plug that into this, right? If x is 2.5 meters, what's y? Well, it's 2.5 meters minus 0.2 times the square of 2.5 meters. 2.5 squared is 6.25. 0.2 times that is 0.125. 2.5 minus 1.25 is 1.25. We estimated 1.1, right? Now remember, that was your estimate, not mine. My estimate would have been exact. But your estimate was pretty good, because now everything's nice and consistent. Okay? So, I can just barely write this here. Since I'm having to write it in the most miserable possible way. It comes out pretty clear. Y equals 2.5 minus meters. Minus, now I did and it's not 2.5 meters squared, it's 2.5 seconds squared per meter. You're not going to be able to read that, but seconds squared over meter. Because of course you got a squared meter per second squared down here, divided into a meter per second squared here, which gives you a second squared per meter, and you can work that out because you did the physics preliminaries with all the units and stuff. That's simple. But make sure you do it. Okay? And this equals, well, I'm getting more, if I did this right, 0.125 meters. And that's very close to the 1.1 meter estimate. So, I mean, it's taken us over an hour. About an hour. But we've worked through this whole situation, just a simple toss of the chalk, right? A lot of insight in this. A lot of insight to be gained by understanding this. So if you don't currently understand everything, flick through the video. Then you don't have to watch every second of it, especially when I'm talking about throwing footballs and stuff, okay? You either have that image in your head or you don't. And looking at it again in the video is not necessarily going to help. But there's a whole lot in here about how you use the equations of motion to analyze projectiles. The X and the Y motions are totally independent, except they share time. The only thing in common between the equation of the motion in this direction and the motion in this direction is time. The motion in this direction has an acceleration of negative g if you choose the y-axis to be upward, right? And this one has the characteristic of acceleration of 0 because there's no force in this direction. Now there is air resistance practically. That probably affects a football being thrown 80 yards. That wasn't my thought. 12, 13. Okay. That's pretty good, isn't it? 12, 13 yards? Most people can't throw it that far. Maybe my memory's wrong, I don't know. Okay. What I just said summarizes the situation. In each case, you have an initial velocity, an initial position, initial velocity times t, and 1/2 of the acceleration times t squared. If acceleration 0, that 1/2 at squared goes away. If your initial position is 0, then your x naught or your y naught goes away. That won't always be the case. Sometimes you want your final position to be 0, but whatever's convenient. You always have the option of making up your own coordinate system. With projectiles, the only restriction is that the x has to be horizontal and the y has to be vertical. You don't want to try to analyze this in a coordinate system where things are tilted, because then gravity has a component in both directions. Okay, and that complicates things immensely. You can do it, you just really don't want to. This is much simpler. Okay, well, that's again what it comes down to, so stop repeating myself, and we'll look at another application.